Let's talk about subqueries in SQL. This is a capability that SQL has to do one query inside of another query, and it often leads to very simple and elegant solutions to otherwise complex queries. So by way of introduction, let's just think about how we might do this particular query. We'd like to list the titles of films whose rental rate is higher than the average rental rate. So there's kind of two different things that are going on there. The average rental rate is one calculation that we need to come up with, and having that value, then we could go find the titles of the films that have a higher rental rate than that average. But this isn't just a question of assembling together a join of multiple tables or that kind of thing. We actually need to come up with that single value that's giving us the average rate and using that to select rows from another query. So one way to approach this is as follows, right? We could first of all calculate what the average rental rate was. So this illustrates that capability. We can say select average rental rate from film, right? We've used the average function or similar ones to it like count and sum as aggregation functions in the past, often in the context of using a group by, but we're perfectly within our rights to use it as a standalone function. So what this is going to do is give us a single value that corresponds to the average of all the rental rates of all the films, $2.98. That's the important part here. I also wanted to illustrate that we can do some formatting with SQL. Again, the select statement just takes a list of expressions, one or more expressions. That can be a star to get all the columns, or a column name, or a simple numeric calculation. In this case, we're calling a built-in function in Postgres called toChar, which takes a numeric value and then a formatting string that says, here's how I'd like you to format this particular value. And there's a bunch of different capabilities of this toChar function in terms of the different ways you can format things, but this is a really simple one. The secret decoder ring is here. A 9 means to encode a digit, and a D means to include the decimal point. So we're saying 2 digits, a decimal point, and 2 more digits. And you can see that that's how we get this thing formatted. So that's just a freebie to let you know how to do formatting that's maybe a little bit more specific than the default. So at any rate, we've now got the value that is the average rental rate, which we can then plug into a second query like this. I guess I asked for just the title, but I'm including some additional information here just to kind of verify what's going on. We're going to grab those pieces of information from the film table, and here's where we use that value that we calculated in the previous query, the average rental rate. And you can see the output here. I've put in a limit clause to keep it all on the slide and stuff, but obviously all of these rental rates are larger than $2.98, which was the average rental rate. So this is fine. We can actually do this in a procedure. We'll see when we start talking about stored procedures that we can define variables in SQL. We might store that temporarily, that rental rate average temporarily in a variable, and then use it again here in the query. But there's a better way to do this. We can use what's called a subquery. So this is exactly the same code, except here at line 5. Instead of having this built-in constant that's just hardwired into this query, we're actually going to ask the database to supply that value on the fly. And we'll do that by including, instead of the constant here, we're going to do this line here that is a subquery. As you can tell, this is a standalone select statement, and it's embedded in parentheses here. That's the syntax that we use to indicate a subquery. So when SQL evaluates this, it's going to see that it's got a subquery. It's going to run that subquery to come up with a specific value, and then use that value to run the larger query. So if we have this hardwired into our query, and the average rental rate changes as we reprice movies or add more movies or whatever, this would not reflect the correct answer to the question, because it would stay fixed at $2.98. But if we do the subquery, then this is going to get run every time we do this query and give us the correct current value for the average rental rate of all of our films. Here's some more general information about using subqueries. First of all, it is possible to use these in pretty much any data manipulation language statement that we want to use. Select, insert, update, delete. any place we want to do an evaluation of some other value or set of values. And here's kind of a laundry list of the ways that it can be used. Note first of all that all these things return a Boolean value. So they're very often going to be used in a where clause, right? Because a where clause is ultimately about determining whether a particular row in an intermediate table is going to survive to the output or not. And that's a Boolean decision. So it makes sense that these things are used in that context. Rather than going through all these up front, I'm going to kind of show you some examples and come back to this slide to maybe say a few more things about each of the examples. But let me just highlight right away that we've just shown you an example of this case. We've got an expression and then a comparator and then enclosed in parentheses a subquery. That's what we have back here in an expression, a comparator, and the subquery. And the subquery is basically returning one value in this case. Now notice if we go back to here, we know that because when we wrote just the standalone select average statement on this slide, that it came back with just a single value. Now it seems a little bit odd maybe that we're using that single value in a general expression, because as we know, it's tables all the way down. So even though this looks like a scalar, it's actually a table with one row and one column in it. The good news is that that's totally acceptable to use any place a scalar constant or whatever would appear elsewhere in SQL. So the fact that this is a single cell table is still cool to use in this context where we're doing a comparison between a particular value from a row using an arithmetic comparison operator. So the subquery needs to return one value, that single-celled table, in order to use this syntax. And the comparison can be any of the numeric comparison operators equal to, less than, or equal to, greater than, less than, and so forth. So that's the one that we've seen so far. Let's take a look at in. So here's the general syntax with in. It's going to be basically providing a kind of a set membership test. So whatever expression is here on the left, we're going to check to see if it is in the set that's returned by this subquery. Again, the parentheses are necessary to indicate to SQL that we've got a subquery going on. Now, what do we mean by set in this context? The idea here is that that subquery is going to return a single column table. And what we're going to do is we're going to go through that entire single column and see if this expression, if the value of that expression occurs in any of the rows of that single column. And if so, this in expression will test true. And if the value of that expression doesn't appear in any of the rows of that single column table, it's going to evaluate to false. So subquery returns exactly one column, and this is kind of similar to the constraint that we see on the subquery in case number 2, where this, in order for this to work, we've got to return just one value because we're going to compare it using one of these scalar comparison operators. In this case, we're going to return a set, which is going to be represented as a single column table. And again, this expression will be true if any value matches that expression. There's also a variant of this called not in, so we can say expression not in subquery, and that just reverses the sense of the test. So let's look at an example of in. So first of all, here's going to be our subquery. We'll sort of work our way from the inside out. This subquery gives us films that had been returned to the store in this date range. You can see here that there's maybe, I don't remember if we've talked about this explicitly before, but one of the ways that you can write a comparison for a where clause is to use this between operator. So you say the name of the expression you're trying to compare, and then you can say between this value and this value, and it'll test true if it's in that range of dates, in this case, inclusive. So what's coming back from this query? Well, it's going to be a list of film IDs, or a table consisting of just a single column that's got film IDs in it from the inventory table. But we're going to be joining inventory with rental, because rental is where we find the return dates that we're interested in to select the particular films that were returned in those dates. And what comes back from this is this single column table that we're going to treat essentially as a set. So if we go back to the definition here, this particular type of subquery expression requires a table that has exactly one column, and we're going to see if each of the values of this expression, which is going to typically be a column, occurs in one of the values in this set, this single column table. So that's what we end up getting from this subquery, the film IDs of all of the movies that were returned in that date range. So now let's take this subquery and use it in the top level query. Again, we were looking for the title of films that were returned in that range. So we're going to look at all the films. So simple select film, I'm adding the film ID here for yucks, but the title is of interest, from the film table where the film ID is in this subquery. Again, the in operator treats that subquery, which has to be a single column table, as a set of values, and if this film ID appears anywhere in that set, then the where clause tests true for that film, and the data for that film that's specified in the select clause is going to be output as part of the result set from this query. Next, we're going to talk about exists. So let's go back to this laundry list of different expressions. So we've now talked about the expression and a comparator, the expression in, and now we're up here looking at exists. So we're going to say exists and then give a subquery, and this is going to be true if the subquery returns at least one row. In other words, the subquery doesn't return an empty table. And let's go back over here and take a look at an example. So here's name of customers who've bought something or who have rented something apparently. So we're going to get the customers' names as our top level query from the customer table. Well, which customers do we want to show in this output? We want to have customers that have purchased something. And we can tell if a customer has purchased something if there is a payment record that uses that customer's ID. So here's our subquery. We're selecting from the payment table, and we're looking for payments that have a customer ID that matches the customer's customer ID. And for each such match, we're going to output a row in this result set that just contains a 1. Now, that seems a little weird here, but remember what we're trying to do here is determine whether there are any payments for this particular customer. And the exists expression here will test true if this result set is non-empty. And so this satisfies that criterion. We could certainly return something else from, say, the payment record if we so chose as the result of this select, but it's kind of a fairly common idiom to just use the value 1 to indicate, hey, yeah, there's something there. So what we would get from this result set would basically just be a collection of rows that had a single column which had a 1 in them corresponding to each of the times that this customer has made a payment. But that's entirely sufficient to trigger the appropriate response from the top level query that if there's anything in this result set, that means that customer has bought something, so let's include them in the output. Here's another example of using exists, where we're now finding customers who've made a payment greater than $11. I don't know why 11, but there it is. Same basic pattern here. We're in the subquery, we're selecting from the payment table, we're using that to join with the customer table because the payment information is found in the payment table. This amount column is in payment, but we want to get a customer ID out of this, or we want to match against this customer ID so that we can tell if any customer made a payment that satisfies that criterion. So again, we're selecting 1. We're just going to get some rows that have just a single column of 1s in them if this particular customer has in fact made a payment in excess of $11. And that will make the exists expression test true if that set is not empty, indicating that that customer made such a payment. Notice that we're also using some aliases for our table names. So payment is being aliased to P, customer is being aliased to C, and then we can use that to qualify our customer IDs according to the particular table that they appear in. And it's also the case here that I actually prefer this syntax with the as, but you don't need to use that. You can just name the alias in your from clause directly. And then we see that this is a list of the customers that satisfy that criterion. The final example with exists is actually the negation of that. So this is exactly the same SQL statement, except I've included a not in there. I've just negated the sense of the exists, And now we get a list of those customers who have not paid a payment in excess of $11. So that's one way to do it. We could, of course, also have changed the comparison that's going on inside the subquery. That would have worked too. Different ways to get the same results. So finally, let's look at the any expression. Let's go back to that list of the expressions. So now I've talked about exists, and we want to look at any. This says that it's going to be true if any of these results is true. Now notice that instead of just doing a simple set membership like we did with in and exists, we've brought the operand back here, right? So that's going to be one of these comparison operands. So we're saying if the value of the expression here using this operand is true for anything that appears in this subquery, then the overall expression is going to be true. Let's go back to the example. What we're doing here is we're starting out, again, this is the inner subquery. We want to find the longest film in each of the film categories. So the film has its length, and then the film category table maps that film to a particular category. Now, in this particular case, all we want to do is get the ID of the film that is the longest in each category, or is at least as long as any other film. So we don't actually have to match, or we don't have to actually join to the category table itself. We can instead just use the film category table and group against the category ID. Right? We're just trying to find the largest value for each category. We don't care what the categories are called in this case, so we can simplify this by just doing a two-way table join. And once we've grouped by that category ID, then in the select statement, we either have to use things that we grouped by or aggregation functions. So the aggregation function we're going to use is max length, which is going to give us the length of the longest film by category ID. I'm not even outputting the category ID, I'm just getting the max length, which is illustrated here in the output. Now, one thing here that's probably new to many of you is this syntax for the inner join. We're used to seeing an inner join where we say something like film category or film inner join film category on film category.filmid equals film.filmid. It turns out that there's a simplification for that syntax in the case where the primary key and the foreign key that refers to that primary key have the same name. And that's what's going on here with this using clause. And I've noted here that using something called A is the same as saying, it means the same as the left-hand side table.a is equal to the right-hand side table.a. So I think I've mentioned this a few times so far, that I don't really care for this convention of using the same value for the foreign key as the primary key. My tendency would be to use the primary key of just ID, and then the foreign keys would be film ID when they refer to the film's primary ID key or ID field. But if you choose to use this convention that our sample database does, and to make those primary and foreign keys the same, you can just use this using clause, which simplifies your queries. So whatever you prefer is totally fine. The point of this example, though, is that we're getting a list of the lengths of the longest films in each category. Okay, and that's coming back as a table. Now let's use that query. So here's the query that we just got done talking about, exactly the same as the subquery. And what we're looking for are films that are at least as long as that. And so now the expression in our where clause, again, it's going to return a Boolean value as all these subquery expressions do. We're going to compare the length of each film to see if it is greater than or equal to any of the values in this subquery. So it's going to go and compare them to any of these values, and if it is at least as long as one of those values, then this will test true, and that particular film will survive to the output of this select statement, and we get these titles as the first few of those. Note also that this is using the any expression. There's also an all version of that says that if this expression is true for all of the values in the subquery, then the overall expression tests to be true. So in the case we have here with any, we're saying that these films are all longer than any one of the longest in each category. So for example, it might be longer than this category, whatever it is. We don't know what the category is itself, even though there are categories that have longer films. So if it was 184.5 minutes, it would survive the test of the any. On the other hand, if we switch this any to say all, now we're saying that this has to be true for all of the values in the subquery, which means that that film would not be accepted or would not pass that test because it was not longer than all of the longest films in the different categories. They'd have to be, at least according to these first 5 values, the film would have to be at least 185 minutes to satisfy that all constraint. So you can use either one. Finally, we've been just looking at any. We can see here that instead of using any, we can also use in if we're doing an equality comparison with the any. These have the same meaning. So here's another example. We're looking for films in one of 2 named categories, and we're going to do in here. So here's the subquery. We're looking for the category ID from the category table where the name of the category is either action or drama. So that's going to give us back a couple of category IDs. We don't have to know what those category IDs are. We just have to know the names of the categories we're looking for. And then this test is basically saying, give us a list of those films that have category IDs in one of those 2 categories, right? So we're using in against a subquery that's returning, again, a set, which we know in this case is going to be structured as a table with a single column. So if this category ID for a film matches either of the values that come back from the category subquery, then they will be included in the overall result set from this query. And that's actually the same as if we were to use equals any. So back here we were using greater than or equal to any, but if we choose to use equal any, it does the same job as this in, and that's illustrated in this next slide. So here, exactly the same query. You can see the only change is that I'm now saying if it's equal to any of those things, that's the same as saying in. So there's a little bit of overlap here in the semantics of some of these operators. When you're doing subqueries, kind of use whichever one seems more natural to the problem at hand or more sensible to you. There's more than one way to do it, and that's totally fine. Finally, here's some links to some resources. So always helpful to go look at the actual manual for these types of things. The Postgres tutorial that I've cited a few times has a really nice treatment of subqueries, talks about some of the queries that we've looked at here. There's also some pretty decent info at W3 Schools about these subqueries as well.